Hello friends, we're going to explain the valence bond theory of tetrabromoethylene or C2Br4. These screenshots show the atomic orbitals. The first one shows only the orbitals, while the second one shows their overlap. This is the VS-EPR diagram of C2Br4. The shape itself is planar because of this double bond between the two carbons. When carbon has a double bond, the resulting molecular structure is always planar. The angles between the two bromines and the carbon are at 120 degrees. However, the angle between the bromines that are in between the double bond are greater than 120 degrees. This is because of the double bond right here that causes more repulsion between the electrons in the molecule. Here we have the box diagram of C2Br4. We'll only show one carbon because both carbons bond the same way. Here we have the ground state of carbon. In order for it to bond, we have to promote one of its electrons in its 2s shell into its 2p shell. This will give us the excited state of carbon. We'll only hybridize these three electrons. We'll explain why we don't have to hybridize this electron in the 2p shell later. When we hybridize, we get sp2 and the 2p left over. In its bonded state, two of the electrons in sp2 will bond with two bromines with the electron in its 4p shell. We'll explain the double bond of carbon using its bonded state. The electrons in blue are from bromine. In order to form its double bond, each carbon will bond with its respective electrons of the same shell. So sp2 will bond with the sp2 of the other carbon, and 2p will bond with the other 2p shell of the other carbon. These bonds do not have the same energy. The bond between the sp2 shell forms a sigma bond, while the bond between the 2p shell forms a pi bond. We'll explain that more with a contour diagram. Here we have the contour diagram of C2Br4. As we can see here, 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 and here, the sp2 orbital of the carbons bond with the 4p orbital of the bromines. The bond angle between the bromine and the carbon are 120, while the bond angle between the bromine and the double angle of the carbon are greater than 120. Each of these bonds form a sigma bond. The double bond, however, is a little bit different. The sp2 orbital that they share are a sigma bond, but the 2 pi orbital that they share have a pi bond. The shape of this molecule is planar, as it is with every carbon that has a double bond. And that's the valence bond theory of C2Br4.